Welcome back, Year 5s, to your maths lesson for Monday. I hope you enjoyed your reading lessons, which was before this. And today we're going to be looking at equivalent fractions in maths. Now, I know many of you get very scared and nervous when you hear the word fraction, but I hope after this lesson you're going to feel quite confident and ready to tackle fractions for this term. This is probably one of the most easiest and basic ways of finding equivalent fractions, and I'm really excited to be teaching this lesson today to you guys. And I'm really sad that I can't do it with you at school, because I'm pretty sure that by the end of this lesson you're going to go, Miss Fink, that maths is so easy and I'm loving fractions. So I'm first going to give you some time to do your starter. So if you'd like to pause your video now and give the starter a go, here are 6 questions for you, 6 nice and easy ones. All of the questions are methods we've been learning about prior to today, and so hopefully you'll whiz through them. So good luck. Right, let's see how you have done. Number 1, the first one is a nice mental calculation there, okay? The fact that this number ends on a 0 is alarm bells going off in my head. So I'm going to look at the numbers before that, and I have 42. Can I do 42 divided by 6? Yes, I can. I need to know my tables, and this is why knowing your tables is so incredibly important. 6 times 7 gives me 42, and then I add the 1 0. If there were 2 zeros, then I would add 2 zeros at the end. So this is our mental calculation. I wouldn't need to go and do my little bus stop method. I can simply look at this number. The fact that it ends on a 0 is alarm bells going off in my head. I look at the numbers prior to that and I go, right, I can do 42 divided by 6. If you are struggling with your times tables, please make sure that you're using all the apps. There's Hit the Button, there's the Pixel app, there's your TT Rockstars. You're welcome to be using all of those to practice your times table. And there is so much on the internet that there really is no excuse for you to be not practicing your timetables every single day. Right, another multiplication sum. Here we go. So setting it out vertically. 38 times 2. Now, some of you could probably do this in your head. However, let's go through the formal method. 2 times 8 is going to be 16. Carry the 1. And 2 times 3 is 6 plus 1 is 7. And I get an answer of 76. Let's just rub this out. Next one, 9 minus 3.05. We have done decimals last week, so let's see how much you remember. Right, whole number. If they don't give me the decimal always goes at the end, and I put in my placeholders. And I'm subtracting, again, making sure I'm subtracting. I've noticed in some of the feedback that we've been getting from everybody is that we are making silly mistakes. We're re-adding instead of subtracting. So there, don't make those silly mistakes. Right, 0 minus 5 I can't do, so I'll need to go next door. Still nothing, so I need to go all the way to the 8. I take away 1. I leave it with 8, carry the 1 over. That becomes 10. However, I still need to regroup the number at the end. I'm taking away another 1, so it becomes 9. 10 minus 5 is 5. 9 minus nothing is 9. Very important that I'm bringing down this decimal, okay? Very, very important. Again, I also saw some silly mistakes last week with children not bringing down that decimal. And 8 minus 3 is 5. Sorry, that little 1 there wasn't meant to go, so let's just rub him out. Right, so my answer there is going to be 5.95. 5.95. Great. Right, another one that we've been doing, which we looked at last week as well, is a decimal multiplied by a whole number. So I'm going to write the number 6.54 multiplied by 8. Right. 8 times 4 is 32. Carry the 3. 8 times 5 is 40, plus 3 is 43, carry the 4. And 8 times 6 is 48, 48 plus 4 is 52. And making sure that I've got 2 numbers after my decimal, So I'm going to count 2 numbers and put my decimal in there. Another way to make a silly mistake is to leave that decimal. So my answer is going to be 52.32. Right. Another one, whole number now. So like our rounding, we write the number down, 9.8. Right. And I go to the number next door. Right, I'm going to the whole number. So we're going to circle the whole number, find the number, look next door. So I'm going to look at the 8. 8 is 5 or more, so we're going to raise up. So this is going to become 9, it's going to become 10. I leave it as a whole number. I did not put a decimal because my question asks there for a whole number. Okay, so I go put the number down, write the number, find the number. I'm looking for the whole number, so I'm going to circle the whole number. Look next door. If it's 5 or more, I'm going to raise the score. If it's 4 or less, I'm going to let it rest. It is 5 or more, so I'm going to raise this number. So after 9 comes 10, and I leave it as 10 because that is a whole number. If I put a decimal in there, I've given a decimal number. And the last one, common denominators. So I'm going to say 3 plus 6 is 9 over 8, 9 eighths. Okay, and that I leave it like that. Some of you might have changed it into a mixed number. So 8 would go into 9 once, and I'm left with 1/8. Okay, but as I've said in many of my previous lessons, it is very important that you just leave it as an improper fraction, because in your tests, you can get a mark for this. And if you change it to a mixed fraction, some of you tend to not do it correctly, and then you've made a silly mistake. So you will get the mark for this. And let's say, for example, you say 8 goes into 1 once, and then you think you've left with 2, and you put 2/8. Then we have to mark it incorrect. So leave it as an improper fraction. Right, hopefully you've done really well with your starter and you've got 6 out of 6. And let's move on. So put everything that's going to distract you away and have a think about this big question. Is it always, sometimes, or never? Alex says, if I split a shape into 4 parts, I have split it into what they call quarters. Do you say that this is always, is this sometimes, or does this never happen? So have a little think. And can you explain why you have given that reasoning? Why have you said always or sometimes or never? You can pause the video and have a little go at that now. Right. It is going to be sometimes. Sometimes would be my answer, because in order for it to be a quarter, it has to be divided into 4 equal parts. Okay, the very important key word there is equal. So if you just split a shape into 4 parts and they're not equal, they will not be called quarters. In order for something to be called a quarter, it has to be split into 4 equal parts. So if it was split into 4 equal parts, we would say that those are quarters. But this question here does not give me the exact terminology, the exact wording. So I don't know if I've simply taken, let's say, a bar, and this is going to be a very bad representation, but you'll understand. And there I have divided into 4 parts. But I cannot call each block a quarter because they are not equal in size. So in order for something to be a quarter, it needs to be equal. Right, so let's look at some of the vocabulary that we're going to be looking at over the next couple of weeks. So what is actually a fraction? What is a fraction to you? So have a think about that question. What do you think the 2 numbers are called? What would we call this top number, and what do we call the bottom number? What does this top number tell us? And what does this bottom number tell us? So have a quick go at answering those 4 questions. So pause the video and let's see how you can get on with that. Right, so a fraction is simply representing part of a whole. Over here, I've got a picture of, let's say, this is a green pie. Don't really want to eat a green pie, but this is a pie, okay? And I have divided this whole pie, or this cake, or into 5 equal parts. See, this is where it becomes very important, because each of these bits are equal, so I can call these parts bits. So this pie or cake has been divided into 5 equal parts. So a fraction is telling me that I have part of a whole. I don't have, I'm looking at the whole picture here. So this is the whole pie and I want a part of it. So this little piece here, this white piece would be part of it. Right, what are the two numbers called? So our top number here is called our numerator, which is the word underneath it. And the bottom number is called our denominator. Okay, numerator and denominator. So that is your terminology for those two numbers. What does the numerator tell us? Well, the numerator tells me that I have taken a shape and I have divided it into this many equal parts. So I divided this pie into 5 equal parts. This is what the denominator is telling me. I've taken something, a shape of sorts, and divided it into 5 equal parts, or a group of people, and they're into 5 equal sections. And then the top number tells me how many of that I have shaded. So in this example, I've got 4 equal pieces that have been shaded. So this top number, the numerator, tells me how many I have, and the bottom number tells me how many pieces, equal pieces, I have divided this whole into. Right, so we're going to be looking at what we call equivalent fractions today. Now, this is what we call a fraction wall, kind of looks like a wall, and it is showing me that I have a whole number here and how I have divided that whole number into different parts. So I have halves, thirds, quarters, fifths, sixths, sevenths, and it can carry on. It just continuously carries on. And you will notice that the bigger the denominator gets, the smaller the size gets. So you can see here a half is quite big compared to, let's say, a 6. All right. So you will notice that this bottom number, the denominator, is quite small in comparison to the 6, which bottom number is a 6. But we will notice that the half is bigger than the 6. So the bigger the bottom number is getting, the bigger the denominator, the smaller your piece is getting. All right. Now, when we're looking at equivalent fractions, all that we're doing is we're making fractions that are equal. So if I have a half here and I have my 6 here, how many 6 do I need in order to make it equal to a half? And hopefully you would have told me that I would need 3 6. Here are my 3 blocks. So I need 3 6 will give me a half. And you can see there that I have exactly the same amount as that amount there. I would like you now to pause the video and do some of your own investigation. So perhaps take a third now. Could you find any other equivalent fractions to a third? So the same amount, but with another fractions. How many of those fractions would you need? How many of those blocks would you need? Okay, see if you can investigate some of those. So have a look. Okay, if I did a quarter, could I have 1/4? No, because they're not the same amount. Okay, 2 quarters, I would have 2 quarters would mean I would have more than a third. So see if you can do some investigation, have a bit of fun with the fraction wall, okay, and see how many you can find. It doesn't have to be thirds. See if you can use quarters or 2 quarters. See if you can use, you could even use, let's say, 2 thirds. All right, so have a go at exploring the fraction wall and finding some equivalent fractions. So pause the video and have a go. Have fun. Ooh, right, so as I said, equivalent fractions take up the same amount of space but are cut into different sized pieces. The trick to doing this without the picture is to remember whatever you do to the top number, you need to do to the bottom. That is the rule of today, okay? The only thing that you need to learn the whole of this lesson is that whatever you do to the one, you need to do the other. It's like being very fair, okay? If you give somebody a piece of cake, you've got to give the other person a piece of cake. You've got to be fair across the board. So let's have a look at what that means in fractions. So equivalent fractions, as we say, are taking up the same amount. And if you look at, you can almost see the word equal in equivalent, okay? Not quite, but when you say the word equivalent, it's got that sound of equal. So we know we're looking at the same amount. Right, so all this means, and some of us, we've been exploring a little bit of this and touching upon it in class at times. So hopefully some of you have remembered this, and this is going to be super easy. So the rule is whatever you do to the one number, you need to do to the other number. So, what have I done to the 4 to get 2? Have I times it or have I divided it? We're only working with times and divide today. So have I times this or have I divided it? Good, you have divided it. Can you tell me what have you divided this number by to get to? The 4 divided by what gives me 2? Great, 4 divided by 2 gives me 2. Now what did I just say the rule is? Whatever we do to the one number, we need to do to the other number. So if I've done 4 divided by 2 is 2, what am I going to do to this number? Very good. I'm also going to divide it by 2. We've got to be equal here, okay? Making sure whatever we do to the one number, we need to do the other. And 2 divided by 2 is 1. Now, when I'm looking at 2/4 and a half, let's have a look at a picture. Now, can you see here, I have 2/4. I have divided my shape up into 4 equal parts. So there I have my quarters. And I have shaded 2 parts of that. And there I get this shape, this sort of half moon. And if I look at a half, I've taken a whole and I've divided it into 2 equal parts. And I've shaded the 1 part. Remember the bottom number here tells me how many times I've divided the shape up into. And the top number tells me how many pieces I have of that. I've shaded 1 part. Can you see that this 2/4 has exactly the same as this half here, okay? Exactly the same amount of space has been taken up here as it has here, all right? So 2/4 is equal to a half. Right, so let's just look at the steps in order for us to follow to make sure that we are definitely going to be successful in working out equivalent fractions today. So first of all, we need to write our numbers down and we need to put an equals to sign. Then we need to look at the information they've given us. They've got a missing number here, but they've given us the 9. So what have I done to the 3 to get 9? I've multiplied it by 3. So the very important rule, whatever you do to the one number, so in this case, the top number, you need to do to the bottom. And it has to be exactly the same, okay? So you're not going to change the numbers now all of a sudden. So I said 3 multiplied by 3 is 9. So then I'm going to say 5 times 3 is, and hopefully you'll get 15. Now it's very important that when you're setting out your work that you're actually drawing in this arrow and you're putting what you are timesing or dividing it by, okay? So for example, if I wanted to find out equals, and let's say I'm going to try and find out this missing fraction numerator here. I would like you to set it out like this. You write down the 2 fractions, and then I would like you to draw the arrows. So they've given me information here. So what have I done to the 12 to get 6? I would like to see these arrows in your book or on your piece of paper. I've said 12 divide by 2 is going to give me 6. And again, I want to see you draw the arrow and say divide by 2, and that is going to give me 2. Okay, 4 divided by 2 is 2. And the reason why I want you to do that is so that I can clearly see that you have understood it and you're not going to make any silly mistakes, okay? That you're saying, you're using that working out method. You're saying 12 divided by 2 is 6, and whatever I do to the one number, I need to do to the other number, okay? Right, so here are just some quick questions. Let's see how you can do. As I say, we're looking at equivalent fractions here. So I have a half, I have 2/4. How many here do I have? So look at how many times I've divided up this whole shape, this whole pizza. How many do I have that I've got left? And over what is the total that I've divided up into? So we're creating equivalent fractions here. Right, hopefully you've said you've got 3 slices and they are that you've cut up your piece of pizza into 6 in total. There are 6 slices in total and you are left with 3. Now you can see a half, 2/4, 3/6 are all equal to one another because you can see here that the pizza is taking up the same amount of space on the plate. Here I have a half, 1 piece out of the 2. Here I have 2/4, 2 pieces out of the 4. And here I have 3/6, 3 pieces out of the 6. So all of these are equivalent fractions to one another. A half is equal to 2/4, which is equal to 3/6. 3/6 is equal to a half. Okay? Right, using the bar model now here, could you please tell me what the two equivalent fractions are? So what is A? What is the fraction of A, the shaded part? And what is this fraction? Have a go. Right, let's see how you did. If it's too short, please pause the video at any time so that you can get the answers. Right, I have one block that is shaded out of 3. I have a third. And here in B, I have 2 blocks shaded out of 6. So my equivalent fraction, again, it's taking up the same amount of space. It's no different. All right, so I've got a third is equal to 2/6, same amount of space, okay? Can you tell me what have I done to these numbers to get them to equivalent fractions? What did I do to the 1 to get 2? What did I do to the 3 to get 6? Good, you said they're multiplied by 2. Right, so very important to find the equivalent fractions. Whatever you do to the numerator, you do to the denominator, or vice versa. So I would like you to have a go now at answering those 4 questions, and let's see how well you do. So pause the video and have a go. Right, let's see how you did. Hopefully you've written out the fraction, and now you're going to be using your arrows. So 3, what did you do to 3 to get 1? You divided it by 3, so you're going to be writing this. So what must I do to the 9? What is the rule? Whatever I do to the one number, excuse me, I must do to the other number. So I'm going to say 9 divided by 3 is going to be 3. So I have 3 9s is equal to a third. Right, the next one, 3. What did I do to the 3 to get 9? Remember, we're only timesing or dividing, not plusing or subtracting. So 3 times 3 is going to give me 9. So whatever I do to the one number, I must do to the other. So I want to see these arrows. I want to see you writing them. So I'm going to copy it exactly the same. 2 times 3 is 6. Right, 20. What did I do to 20 to get 4? And the reason why I'm doing this arrow is that I'm not doing it the other way around. I'm not saying 4 to 20. I'm saying 20 to 4. What am I doing from 20 to get me to 4? Can you see how my arrow is going in that direction? And I'm going to be dividing it by 5. And 5, again, whatever I do to the one number, I must do to the other. 5 divided by 5 is 1. And the last one, again, putting my arrow to show me which direction I'm going in. 25 divide by 25 is going to give me 1. And 100 divide by 25. So how many 25s can go into 100? And that'll be 4, so I have a quarter. Right, a little bit of a challenge here. Have a think. What fraction is the odd one out? I have these fractions, and now we're using equivalent fractions. So have a think about the bottom numbers especially. Which one of these numbers would be the odd one out? Have a go. So pause the video and see how you do. Okay, let's have a look. I've got 12s, 12s, 6, and 9s. Okay, so look at the bottom numbers. When you're looking at equivalent fractions, these numbers need to have to go into the bottom numbers. So I've got 12 and 12. Both those numbers are fine. Okay, I've got 6. 6 can go into 12 times 2. So I can say times 2, and that would give me 12. But is 9 going to give me 6 or 12? No, it is not. So the fraction is the odd one out, and that will not become an equivalent fraction, would be 6 9s, because 9 cannot go into 6 and it cannot go into 12. So therefore this would be the odd one out, whereas my 6 could go into 12, and 12 obviously can go into 12 as well. Right, have a go at these questions now and see how you get on. So pause the video and let's see you go. Great, let's see how you have done. 12, what have I done to the 12? Again, making sure that arrow is going in this direction because I'm going from here to there. 12, divide by 4. Again, knowing my table is exceptionally important. So whatever I do to the one number, I need to do to the other, and I want to be seeing these arrows, and I want to be seeing what you're doing, and I'm going to end up with 1. 4 divided by 4 is 1. 12 to 4, again, is going to be dividing it by 3. So I'm going to say 6 divide by 3, and that is going to give me an answer of 2. And 12 divide by 6 is going to give me 2. So 6 divide by 6 is going to give me 1. Okay. True or false? Is 2/3 and 8/9 equivalent? So let's have a look. Let's investigate. I'm going to do the first one with you, and you can do the second one on your own. If you think that you want to go for it on your own, then pause the video now and then give it a go. But if you need a bit of help, then let's have a look at this one together. So I have 2/3 and I have 8/9. So I'm going to set up my work like normal. Right, I'm going to say 3 times what gives me 9? 3 times 3. Now, whatever I do to the one number, I must do to the other number. So I'm going to say 2 times 3. And is 2 times 3 going to give me 8? No, it is not. What is 2 times 3? It is 6. So therefore, 8/9 is not an equivalent fraction. So this is going to be false. Now I'd like you to see if you can have a go at this one. Set out those two fractions. Whatever you do to the one number, then do to the other and see if you get it. Right, so pause the video and have a go. Right, let's have a look. 2/5 and 4/10. Right, so I'm going to say 5 times 2 gives me 10, and 2 times 2 will give me 4. So that one will be true. 5 times 2 is 10, 2 times 2. Remember, whatever I do to the one number, I need to do to the other, and that will give me 4. Right, so this is your work for today. On the next slides, you will see what you need to do. All right, those of you who want a slightly easier version, you're going to do the 2 chilies, and those of you who want a bit more of a challenging version, you can do the 3 chilies, and then there is a challenge at the end, okay? If you are finishing quite quickly, please give the challenge a go. I have noticed not many of you are doing the challenges, especially those children who are doing the 3 chilies. It is your responsibility to making sure that you're doing as much as you can to secure your maths knowledge. Then there is a little equivalent fractions quiz on BBC Bite Size. So there is the link. I don't think you can click on it, but if you search, you use that link to search it on Google, it should come up for you. And there is a little quiz for you to do of multiple choice online. So you don't have to write anything down. It's all on your screen, and you can see how well you've done with equivalent fractions. So if you need to, you can just put in BBC Bite Size equivalent fractions. In fact, that's what I just Googled, and it came up for me. So that's a bit of fun to do as an extension after your work. And then the answers will be on the next slides as well. So if you need to fast forward to get to your answers, you can do so. So, oh, that's the challenge. So let's just pause on the challenge very quickly. So you can come back to the challenge, but these are the 2 questions, okay? So those of you who are wanting to do the challenge, here they are. And then I will do the questions now as well. So if you are wanting to do the challenge, you're welcome to come back to this after you've finished your work, and then you can have a go at this, all right? So there are just 2 little questions. See if you can challenge yourself at the end of your activity. I am going to give you the answers now as well. So if you are wanting to do the challenge, I'd like you to fast forward to your chili, and then you can get going with your work. And then if you finish, come back to this and then see what your answer is. Right, so here are the answers. So if you need to pause the video to check your answer, please do so. Right, so this is the 2 chili activity. You're going to write the fractions down, and then underneath, you're going to then set out your work. So I will do number 1 as an example. So I'm going to write a half is equal to 6, and I've got a gap there. Okay, so your work should be looking exactly like my work. So I'm going to say 2 times what is 6 is going to be multiplied by 3, and I'm going to say 1 times 3 is 3. Okay, and that is how I would like to see your work set out. And then these 3 questions are like the ones we did earlier. Which one of those are the odd ones out? Okay, see if you can figure them out. So you can pause your video now, and then when you're done, the answers will be on the next slide for you. So enjoy that. Right, hopefully you've whizzed through those equivalent fractions if you're doing the 2 chilies. Here are your answers. Pause the video, give it a go, and then if you would like, go back and see if you can do the challenge for me, the White Rose challenge, and see if you can do, even if you do one of the challenges. And then there's that BBC equivalent fractions quiz to see how well you have retained your information. Right, 3 chilies, here you go. Again, I'll quickly do the first one with you so that you can see exactly how I expect your setting out to be. So you're going to set out your 2 fractions. What do you do to 8 to get 16? You multiply it by 2. I want to see these arrows. I want to see you, whatever you do to one number, you do to the other. And your answer then is going to be 10. Okay, I want to see the setting out. So you're going to give that a go. And then again, you've got the odd one out. So try and see if you can figure out which one is the odd one. Just like we did in our practice ones. Again, if you have finished, I would really like you to go and challenge yourself with those 2 challenges, especially if you are doing the 3 chilies. You've probably whizzed through these questions, and now I would like you to go back and have a look at the challenges and see if you can answer those 2 questions. Okay, and then if you finish, you can go and do your BBC quiz. All right, so have a go. Good luck. Right, and hopefully you whizzed through that. I do notice some of these fractions are a little bit blurry. I do apologize. Hopefully you can make out that that is a quarter, 2/3, 3/5, and a half. And here are your odd fractions that don't match up, okay? So hopefully you whizzed through that. As I say, if you're done, go back now, go and do those challenges for me. We'd love to also see your work, so please send your work to year5@thepalmeracademy.com. And remember, if at any point that you're struggling, go back in the video and go through the starter and the inputs again to help you. Right, that is all for me for math today. I hope you have a wonderful, wonderful day. Enjoy your lessons. Please let us know how you're doing. We'd love to hear from you from Teams or sending us an email. Otherwise, take care and have a wonderful day.